All right, hi guys. So this is the video for demonstrating conservation of mass with balanced equations. I'm trying something different. I'm using my phone as a document camera, so this may or may not work. But what I did was I took notes or wrote down my notes over balancing equations, so that way we could go through and discuss it. So this is your demonstrating conservation of mass with balanced equation lesson. The main thing is we want to try to get the number of atoms in our reactant side and the number of atoms on the product side to be the same. So there are some steps to this. The first thing is going to be you need to write a skeleton equation. So you need to have some sort of a skeleton, obviously unbalanced equation. You're going to count the number of atoms on each side. So you're going to look at both sides, the reactants and the products, and make a list of what elements you have and how many you have. And then if you balance in this order, it will make your life a lot easier. If you balance metals first and then nonmetals and then polyatomic ions, keep those grouped together if you can. And I'll show you an example of what I mean by that in just a minute. And then when you're done, recheck your totals just to make sure that they have the same number on both sides. So that's pretty much how to balance an equation. There are a few other things that are talked about in this lesson, and I just wanted to go through them with you. So, like when we look at the example they give you, they say they have 6 carbon dioxides. Well, the coefficient in front of that is a 6. That coefficient you will need to distribute to all elements in the compound. So it literally means that you have 6 carbon dioxide molecules or 6 moles of carbon dioxide. So another way to write it out would be to write out all 6 of those. Well, you don't want to write out all 6 of those when it's easier to just write 6 CO2. So the way to figure out your total number of atoms is you distribute. So we're going to distribute 6 CO2 or 6 to carbon, give me 6 carbons, and then 6 to the oxygen, and it's going to give me 12 oxygens. The next one, an example, is doing something that has a polyatomic ion in it. So like this one has nitrate. And that polyatomic ion is going to be grouped together. Ooh, there's a lot of feedback. So the polyatomic ion is nitrate. And so we're going to ignore that 3 for just a minute. Right now, I'm just going to look at what's in the parentheses, and the subscript behind it is going to get distributed to everything inside the parentheses. So it won't get distributed to the barium, but it will get distributed to the nitrogen and the oxygen. So if you're figuring out your total number of atoms that you have, just ignoring the 3 for right now, you have 2 nitrogens, 6 oxygens, and then 1 barium. And then you will distribute that 3 to everything. And that's how I get the totals of 6 nitrogens, 18 oxygens, and 3 bariums. So the last thing I want to do is just work through a few examples with you. So the examples that it gives you one that's like already balanced, where it has silver plus 4 nitric acids, gives you silver nitrate, nitrogen dioxide, and water. Basically, having the 2 nitric acids is just like me writing it twice, but it's so much easier. Just condense it down and say I have 2 nitrates. So all you have to do here to make sure that they're the same on both sides is just count. You have 1 silver, you have 2 NO3s, but you also have hold on, it's not the same. There's 5 on both sides. I'll have to go back and look at this one again because it's clearly not balanced, or at least I just didn't write it down correctly. but it's not balanced because oh yes, it is. Never mind, because I have 5 oxygens and then one more oxygen there. I forgot that other little oxygen on water. So there are 6 oxygens on this side, whereas there are also 6 oxygens on this side. So yes, it is balanced. Okay, looking at the next one. So magnesium plus oxygen, they give you just plain magnesium oxide. So they just give you plain MgO. Well, when you work that out, you have 2 magnesiums on this side and 2 oxygens on this side, but you start out with only 1 magnesium and 1 oxygen. So I look at the side that I need more of, and I need more on the product side. So to get to 2, so I put the coefficient in front of the magnesium oxide, and that now applies to everything. Applies to the magnesium and the oxygen, so it makes it balance. Another one I'm going to just show you really quick is this one right here. So you have S8 plus oxygen gives you sulfur dioxide, so SO2. So in the beginning, on the reactant side, you have 8 sulfurs and 2 oxygens. And then on this side, you have 1 sulfur and 2 oxygens. So your oxygens are balanced, but your sulfurs aren't. So you have to put an 8 in front of this to balance your sulfurs. So that now gives you 8 sulfurs, but it also gives you 16 oxygens. How are you going to get 16 oxygens on this side when you have 2 of them? You just put an 8 in front of that. 8 times 2 is now 16, and it's balanced. So this one down here, I'm going to try to write and balance with you. So we've got this polyatomic ion of KOH. So we have potassium hydroxide and we have copper nitrate yields potassium nitrate and copper hydroxide. So I'm going to go ahead and just do my counts. I have 1 potassium. I'm going to keep hydroxide the same together because it's together on both sides. So I'm just going to treat it as one entity, and I have 1 hydroxide. I would have 1 copper, and I'm going to do the same thing with nitrate that I did with the hydroxide. I'm going to keep it together because it's together on both sides. If it wasn't together on both sides, like if it was broke apart, if it wasn't NO3 anymore, then I would have to break them apart into individual atoms. But in this case, I can keep them together. So on this side, I have 1 potassium. I have 1 of the nitrate groups. I have 1 copper, and I have 2 hydroxides. So if I go in the order that I gave you guys earlier, I do my metals first. Well, they're balanced with 1 and 1. The nonmetals in this case are just polyatomic ions. So really it's making sure that I get my polyatomic ions balanced. And it doesn't matter which one I do first. So let's just do nitrate first. If I have 2 nitrates on this side, I have to get 2 on this side. So the only way to get 2 is to put a 2 in front of it. And that now gives me 2 potassiums. So to fix that, I put a 2 in front of this. And now I have 2 potassiums, but that also gives me 2 hydroxides. So everything should now be balanced. And that's all you have to do. So these coefficients would be 1s, and that's it. So let me know if you have any other questions.